Hello and welcome to the transformations video, starting a brand new unit. I'm hoping that you've done transformations before in the past, but it's probably been a little while. So I wanted to make sure I spent some time talking about what possible transformations we can go over, and then we'll go through a few problems together. So when we're dealing with transformations for this unit, we're going to be dealing with square functions or quadratics, as well as cubic functions. So we can see in examples 1 and 3 here. We have 3 here for a cube, we have square here for a quadratic, and we're always going to have the same type of transformations. So if we take a look at the possible transformation, we'll have some function, let's call it g of x, is equal to a times x minus h, and this could be maybe squared, this could be cubed, depending on whatever the function is, plus k. Now just a reminder, a is going to be our vertical stretch or compression, like shrink. H, or I'm going to say negative h, is a shift left or right. Oops. And K is going to be a shift up or down. So it's going to be it's going to be up to us to determine how this is being shifted and where it's going. And in order to do that, we're going to need to know our parent functions. So if we take a look at problem 1, g of x, we can see that, okay, there's a cube right here. So the parent function is x cubed. Now, for the parent function, let's also take a look at the parent table. What are the original points we can plot? We can do an x and a y. We've already covered this a little bit, but I'm going to use the values -2, -1, 0, 1, and 2. I'm always going to start with these x values for x cubed or x squared. And then I'm going to take these numbers, plug them into my parent function. So if I plug in a 2, 2 cubed is 8. If I plug in a 1, 1 cubed is 1. 0 cubed is 0. -1 cubed is -1. And -2 cubed is -8. So if I was to plot these points on a graph, they would look something like this. So this is my parent graph. So this is my graph of f of x. But this is not what we want. We want to state the transformations, show the t-table, and then sketch the new graph, so with these transformations. So first thing I want to do is I want to take a look and see what happened here. Well, I don't see anything out in front, so I don't have any vertical stretches or compressions. But let's see, I do see an h, so we're shifting left or right. In this case, it's a -2. So since it's negative, whatever value we have, it's a -2 or a +2. So we're going to say we are moving, let's do this. Yeah, let's do this in blue. To the right by 2. So step 1, listing my transformations. First things that happens is there is a horizontal shift to the right 2 units. And then the next thing that I see is a k value, something at the very end. Since that's a +1, it's going up. So we have a vertical or up or down shift up 1 unit. So I'm kind of giving the direction, the number of units, whether it's horizontal or vertical. Whenever we're doing something horizontal or shifting left or right, it's always going to be a little tricky because it's going the opposite way of what we think. So from here, you can count from the dots that we've already listed for our parent function, or you can use a transformation table. So for our transformation table, the horizontal stuff deals with our x values, and the vertical stuff deals with our y values. Or you can think of it that h deals with x, and a and k deal with y. So when we're dealing with our x values, I'm going to take all of my x values and I'm going to apply the transformation numerically, or in this case, add 2. You're going to want to change the sign or flip the sign whenever you're dealing with the x values. So since it was minus 2 in the equation, we're going to use a plus 2 out here. And I'm just going to add 2 to all of my x values. So it's going to give me a 0, 1, 2, 3, and 4. This is going to take all my x values and move them to the right. For my y values, what you see is what you get. There was a plus 1 in the equation, so we're just going to add 1 to all of our y values. So this is going to give us -7, 0, 1, 2, and 9. So for us, these are all the transformations that we have, and now we're going to graph our new points, so whatever we have on the outside. So these are our new x values, and these are our new y values. So we've done part A, listing our transformations or stating the transformations. Part B is show the transformation t-table. That's what we have right here. Part C is sketch the graph. So let's do that. I'll do that in blue. So to sketch the graph, let's see, we'll have the point 0, -7. We'll have the point 1, 0. We'll have the point 2, 1. We'll have the point 3, 2. And we'll have the point 4, 9, which goes off the graph, but it's going to be somewhere up here. So this right here is our g of x, or our transformed graph. Now, if we take a look at f of x, or our parent graph, we can see that we took all of the points, moved them to the right 2, and up 1. To the right 2, up 1, right 2, up 1, right 2, up 1. So we can see that that transformation's already done. Now, you don't have to graph f of x or the parent function. I just find that sometimes it helps me visually see what's going on. But that's problem 1. Let's try this again with problem number 3. Oops. So for problem number 3, again, I'm going to look to see what's happening out in front. Well, we have something out in front here. This is going to deal with our vertical, or up and down, stretch or compression. But since it's negative, negative means it's going to be a reflection. So I'm going to highlight that and write that down. Negative out in front means reflect, or you can think of that like flip. So when we list the transformations, we can say, well, the first thing that's going on here is we're going to reflect over the x-axis. And the next thing I see is that +3 on the outside. Since it's not inside a parentheses like that -2 was up here, means that's going to be our k value. So we have a vertical shift up 3 units. So we're reflecting over the x-axis, and we have a vertical shift up 3 units. So these are all things that affect our y values. And to take a look at how this happens, let's graph our parent function. Again, you're not required to do this, but I find that this helps me. So again, I'm going to use the points -2, -1, 0, 1, and 2. And then I'm going to plug these into my parent function of x squared, because this has a squared on it. So let's see, 2 squared is 4, 1 squared is 1, 0, -1 squared is 1, -2 squared is 4. So my parent function looks something like this. Whoops, there we go. So there's my parent function. So what I want to do first is reflect over the x-axis. Now I know it says x-axis, but if we're going to reflect over the x-axis, it means we're going up here to down here. So it's going from positive y values to negative y values. So what I'm going to do is I'm first going to multiply my y values by a -1. Oh, I do not leave myself enough space. So if I multiply my y values by -1, I'm going to get -4, -1, 0, -1, and -4. Next, like I said earlier, we're shifting up 3 units, so I'm going to add 3 to my y values. Now I'm going to be adding that to my new y values here, not the ones in green for the parent function, but the new ones here. It is important that you reflect first or multiply by -1 first and then add 3, because in our order of operations, you got to multiply and then add. So when I add 3 to all of these values, we get -1, 2, 3, 2, and -1. So when I graph my transformed graph, these are going to be my new y values, but nothing happened to our x values, so we're just going to use the old x values that we had. So when we graph our points, we're going to have the point -2, -1. We're going to have the point -1, 2. Have the point 0, 3, 1, 2, and 2, -1. So we can see here that our graph was reflected and it got moved up. So this is our new function of g of x. This was our parent function of f of x. Again, you don't have to graph that, but you can if you want. I got a little uneven. But again, this is the stating the transformations, using your transformation table, graphing what you can. So that's the first step. That's going from equation to graph. But what if we went from graph to equation? I think this one goes a little faster. Let's take a look at a few more problems. I'm going to bring this in. We're going to move all the way down to problem 13. So that's in a few pages from now. But for these type of problems where we already have the graph, all we need to do is identify the parent function, f of x. So that's either going to be x squared or x cubed. And then write an equation for the function given. So if we take a look at problem 13 here, I look at that and I go, you know what? That's a parabola. My parent function here is f of x is equal to x squared. Boom, done with first part. Now the next part gets a little trickier and it's saying, what have we done, right? What got moved around? The first thing I'm going to check for is to see if there was a vertical stretch, compression, or reflection. So I'm going to start at my vertex, or kind of an inflection point, to my next nice point. And I see that we're moving up and over. 1 and 1. And you know what? That's exactly what it looks like on the parent function. So if I'm just going up 1 and over 1, just like my parent function, no vertical stretch or compression. So this is, again, from, we can just say y is equal to a x minus h squared plus k. So a, I don't have anything. H is my horizontal shift. So I see that we moved 2 points this way, and we went 1 point up to get to here, to get to that vertex. So when I write out my new equation, I'm going to say that g of x is equal to, I don't have an a value. We can write 1 if we want to, but you don't have to. We'll have x minus whichever number we have right here. So it's always going to be x minus this number. So in this case, -2 squared, and then however much we moved up or down. In this case, we moved up 1, it's going to be +1. Now, I don't want you to leave this for me like this. We have this minus a -2, so we're going to turn this into a plus. So we can say our final answer for this one is g of x is equal to, you can put the 1 there, you don't need to, x plus 2 squared plus 1. So again, this kind of shows, oh, you know, whenever you're going left to right, you have to flip the value. This +2 we move to the left. So that's how I know I've done this correctly. But this is my parent function up here, and this is my new function. That's all we've got to do. So let's try this a few more times. Let's take a look at problem number 15. I take a look at 15, I go, okay, you know what? Both my ends are facing in different directions. This tells me that my parent graph is x cubed. First part, done. Now let's see if we have any vertical stretches, compressions, or reflections. I'm gonna look for that little inflection point there, and I'm gonna look for my next nice point to the right, which is here. Now normally we go up 1 and over 1, just like we do for x squared, but here we're going down 1 and over 1. So if we're going down 1 and we have a negative here, that negative means reflect. So if we have a negative, if we're moving downward instead of up to get to the next nice point, that means that there's a reflection. So we'll stick a negative out in front. Next, we'll look to see how we've moved around. Well, it looks like this point is normally, oops, wrong color. This point is normally right here at 0, 0, but I got moved to the left. Didn't get moved up and down at all, but I got moved 2 to the left. So when I write out my equation, I'm going to say that we have g of x is equal to negative, a reflection. I'm going to use a parentheses, x minus a negative 2 again. Oh, pardon me, not with a square, with a cube. I know that I should put a parentheses around the x with the reflection if I also have a horizontal shift happening. Again, don't leave here. We got subtracting a negative, so we're going to combine all this to be g of x is equal to negative x plus 2 cubed. And this is our transformed equation. Here's our parent equation. Let's just do this 2 more times. These go pretty quick. So we take a look at 17. Oh, this one's facing down. I think we have another reflection. So again, normally we start here, and then to get to our next nice point on the right, we move down 3 and over 1. So we move down 3 and over 1. Well, this number right here, how far we had to move down, that tells us, well, the negative says reflect, but the 3 says there was a stretch. It got stretched out really skinny. So we know there was a reflection and a stretch. But if we take a look to see, hey, how far did this move from 0, 0? Well, it didn't move at all. So we don't have any shifts left or right. We don't have any shifts up or down. All we have is our reflection and our stretch. So when we take a look at our parent equation, we can say, hey, both of our ends are going in the same direction. It looks like a parabola. We got f of x is equal to x squared. And for our transformed equation, we've got g of x is equal to, let's see, we have a reflection, and we have a stretch of 3. So negative 3 with an x squared function. And there we go. That's it. That's our transformed equation. Let's do this just once more. Let's take a look at 18. So for 18, again, let's look from our inflection point to our next nice point, going up 1 and over 1. Nothing changed there. That's how it's supposed to be. So we don't have any reflections. We don't have a stretch. We don't have a compression. But let's see how far we've shifted over to get from here. Looks like we shifted 2 to the right and up 1. So when we come up with our equations, I say, you know what? My ends are going in 2 different directions. This looks like a cubic function. So f of x is equal to x cubed. There's our parent function. And for our transformed function, we're going to have g of x is equal to, let's see, we don't have any stretches, compressions, reflections. We do have x minus however far we shifted. So we shifted over 2. And that's going to be inside our type of function. So x minus 2 cubed. Then we moved up 1. So plus 1. And there's our transformed equation. So I think it goes a little faster to go from graph to equation than equation to graph. So I want to make sure we spent more time on the first type of questions in our Go formative. So watch this video, enjoy the weekend, let me know if you have any questions, and I look forward to seeing you on Monday.